This is Unit 6, video number 5, phase changes. Now we're going to look at phase changes. We understand how temperature changes inside a phase, but what happens when a solid is ready to convert into a liquid? We call that melting. Okay? Well, there's some heat, and it's different from the specific heat necessary to melt the substance. Same thing when the liquid's turning into the vapor or boiling. There's a certain heat that's necessary to change the substance from the liquid to the vapor phase. So to do that, we're going to have a couple of names we have to be aware of. When we're changing the liquid into the gas, we call that the heat of vaporization, or we use delta H VAP. We call that heat of vaporization. When we're changing the solid into liquid, it's called the heat of fusion. Heat of fusion is delta H FUS. Now obviously, both of these correspond if we're going the other way, meaning if we're going from steam back to liquid water, we're still going to use the heat of vaporization. We're just going to change the sign. Okay? If we're going from ice back to liquid water, then we're going to use the heat of vaporization. We're just going to use that would be the heat of fusion. We're going to use the heat of fusion. If I'm going from liquid back to the solid, then we would use the negative of the heat of fusion. So we also have heat of sublimation. Sublimation skips the actual melting phase, goes directly from the solid into the vapor. But the heat of sublimation is always equal to the sum of the heat of vaporization and heat of fusion. So let's do a couple calculations. My first problem here, I'm trying to find the mass of water present. And 26.4 kilojoules is necessary to boil that water once it's at 100 degrees Celsius. So notice, we're not concerned with changing the temperature of water. All we're concerned with is boiling it. So it's already at 100. How much heat do we have to put in to continue it all the way into the vapor phase? You know, if you're boiling water and you turn the heat off, it stops boiling. So that means it needs a continual input of heat. And we're going to figure out how much heat is necessary. So the heat of vaporization of water is 40.67 kilojoules per mole. So let's do the calculation here. The Q here of our vaporization is going to be equal to the heat of vaporization times the number of moles. You can see this heat of vaporization is given in kilojoules per mole. Now, the heat of vaporization can be given as kilojoules per gram or kilojoules per kilogram is a very common form. We're just going to do it in kilojoules per mole. You know how to convert grams to moles and moles to grams, so it shouldn't matter which one. It's just, give me the unit and I'll do the proper calculation. So if it's in moles, I multiply by the moles. If it was per mass, I would multiply by the mass. Okay, so let's calculate this. We've got 26.4 kilojoules. And we want to know the mass. To determine the mass, we're going to need the number of moles. So 26.4 kilojoules equals the heat of vaporization, 40.67 kilojoules per mole, times the number of moles. Divide by 40.67, and the number of moles equals 0.649. Okay, we don't have quite a mole here because a mole would take a full 40.67 kilojoules, but this only required 26.4. I know how to change this into mass. The mass is equal to 0.649 times the molar mass, which is 18.02 grams per mole for water, and my mass is going to be equal to 11.7 grams. So that means this amount of heat will boil 11.7 grams. You know that's not very much, so it takes a lot of energy to boil water. Okay, let's do a heat of fusion calculation. What is the heat of fusion of lead if 11.5 kilojoules will melt 50 grams once it's at its melting point? Again, specific heat is what we use to change temperature. Here we're just melting. So we already have the lead at its melting point. We've got 50 grams and 11.5 kilojoules. Well, the Q of fusion is going to be equal to the heat of fusion times the number of moles. We're going to calculate the heat of fusion in kilojoules per mole. So we know the Q of fusion here is 11.5 kilojoules. and we're calculating the heat of fusion, and we need number of moles, but we've got grams. Well, we know how to calculate the moles. The moles is going to be equal to 50, oops, put the decimal in the right place, 50 grams times, and lead is 207.2 grams per mole. Plug that into the calculator, we're going to get 0.241 moles. So now we know the number of moles. Let's put that in over here, 0.241 moles. And you can tell we're going to divide both sides by 0.241, and the heat of fusion is going to be equal to, let's go,